Marco, what's going on?
Quite a few things. I'm looking forward to the next minutes. We're going to talk about books, I heard.
About books?
Yeah, I want to talk about books. I want to talk
Famous
about
books.
I want to talk about...
Apologies. That kind
Gesundheit.
Of yeah. Bless you. Okay, and about Spotify. And Spotify is famous for, of course, one thing, and it's not music in engineering.
At least in software engineering, that's
Yes.
true. I think we should talk about AI, because everyone talks about AI.
Yeah, AI is one part of it.
AI will
it's
be part of it.
about team structures that will evolve, will have to evolve, and will constantly change. And this is something what we have to kind of orchestrate as leadership in engineering. What else? Full stack engineers, some tips and tricks, how you get this done.
People. We're going to talk about people. Looking forward to that, Raphael.
About an old book. And yeah, let's kick this off.
Let's go.
Let's go.
Today we want to talk about an interesting topic.
Yes.
It has to do with architecture, but of a special kind,
right?
Yeah, special kind. Teams and team structures is something that we want to talk about. You have quite some experience with this, I heard.
Yeah, I heard this too. I'm not sure if it's true, but I also heard that you have experience in that area, right?
I heard something similar.
Yeah.
Yes. Oh, come on, let's stop joking. We know that we both seen our share, the good, the bad, and the ugly, and we want to talk about it because every time that we're discussing things, we're finding out new things that we haven't heard before.
It always comes back to people, right? And I mean, there's this wonderful book, you likely know this, Peopleware. I think it was written somewhere in the 80s or 90s. It was like a tech book back in the days when people were working in cubicles and IBM big servers were the thing. And old book, big insight. It's always about teams and about people, right? And so this is what we're going to talk about today. And also architecture is super important, tech architecture. But if people don't work together properly, you can throw away the tech architecture and the whole business concept, right? So it's this architecture. I like this quite a lot.
Yeah.
What do you think is a good way to organize a team? I mean, or how large is the team you're leading currently?
It's an interesting question because I know you are the consultant. You normally say this. It depends.
Yes.
But this time I have to steal that from you.
Okay.
It depends.
It depends. Okay.
So currently I have a team size of 180 plus people.
Wow.
We're still growing. And it's actually the largest department I've led so far. Normally I've been like in the size of 30s or 50s or maybe even 80. This time it's becoming really big, and that's also where I'm learning quite a lot. Interesting things.
And how did you organize the teams? Is there one 90 people front-end team and another 90 people back-end team, or what's your experience with that?
So the short answer is no.
Okay, that's good. That's interesting. It's good.
I'm trying to follow a few concepts here that I learned over my career. And maybe it makes sense that we start maybe on how like growth can look like, because normally like 180 people don't come out of nowhere. They don't pop out of the thin air, but this is normally like a growth process. And we start with a few people, a handful of people when we're a startup, then we're becoming something bigger, and then we're becoming something bigger. And I find, I think I'm not the only one, but I can only talk about my own opinion here, that the organizational architecture is something that needs to be very fluid. It needs to fit the needs of the company. And this means that there is no ideal organizational setup, but there are many ideal organizational setups depending on the size that you're in, depending on the context that you're in. I think you've seen something similar, right?
Yeah, that's totally true. I like the fluid concept you just mentioned, because in many cases, people think that we are now changing the organization and this will be the structure we're going to use until the end of times. And that's simply not true. When the organization grows, you have to restructure the teams, and like your employees and everything working as part of the teams has to be open to that. And even when the team structure is fixed and is kind of working, you sometimes have the need in one team for maybe a special developer that then has to join from another team, right? So people have to really adapt to this, and this fluidity is super, super important, I guess. It's the key concept. It's also like, I mean, there are many different team structures that can work, and especially if you have good people, then like no matter what team structure you choose, it will work. But if you have the wrong people, nothing will work. So it's again, it comes down to people. But yeah, and in terms of front end and back end, that's also very true. When companies start small, it's just like one small team, like maybe 5 people. They work together as one team. There is one person does front end, or 2 people do front end, 3 people do back end. And then once it grows, they kind of try to stay in this front end back end organization, which works until a certain size, maybe 8, 9, 10 people. You have 2 teams, one front end, one back end, but at some point this breaks down because you lose the focus of the product, and the members of the teams don't know what they will deliver. They just think in their technical terms, and then it becomes super interesting. And this is, I think, what you also mentioned. So how would you organize the teams then, or what's your recommendations? Or maybe I'm a startup founder. I now have 20 engineers. I have a 10 people front end team, a 10 people back end team. Delivery slows down. Nobody's interested in business results or in delivering something completely end to end. Things are halfway finished. Backend team says it's done. Front end team says I'm still waiting for the backend. And
yeah, sounds very
sounds classic.
Yeah. Sounds very
What would you do then?
So I would start maybe 2 steps before, and I have like one belief, and that is that the team structure is supposed to support the business to grow. They are serving a certain purpose, and the purpose is not to build a front end or a back end, but the purpose is to deliver a certain feature, a certain functionality, a certain value proposal that then is supposed to make the business successful. So I follow the belief to structure the team to follow the flow of the work. And you can start that already when you only have 5 people. But it's not as obvious because like if there's something to be done, you normally have maybe some generalistic people, some full stack people maybe already, because you need them. You can't hire 10, you can't afford this many people. So you're hiring people that are feeling comfortable in working with all areas. But the more people you're hiring, the more specialized people become that you're hiring, because you want to get the best of best in class, or the best that you can afford. And then something very human happens, and that is the system that you're building becomes more complex. And what I noticed is when things are getting more complex, the people inside that system are trying to create some kind of area where they feel more comfortable. And this is where I need to jump in, and this is where I need to help them, because if I don't do this, then they split themselves up in the most comfortable way, which is into their tribes. Oh, let's collect all of the front-end people and let's collect all of the back-end people. But in reality, we should rather follow the flow of the work and understand maybe we need to create these so-called cross-functional teams.
Yeah.
And you can start very early, but it really becomes effective if you're like 10, 15, 20 people, when you suddenly are not a one-team company, but you suddenly have 3, 4, 5, maybe even 6 engineering teams.
So
you've seen that, right?
Yeah, that's right. But what do you mean by the flow of work? That's a new definition for me, or is it a new definition? What do you mean by that?
I oriented myself on follow the money, like the FBI like police when they're trying to find the criminals. They're following the trace of the money to the source, because it basically helps them understand who's doing what and why. And I said, like, follow the work. Like, that's why we are here. We as software engineers are hired to deliver a certain value. Our purpose is not to write the most beautiful code or the most elegant adoption of a certain pattern or whatever. We're here to make the business successful, and the business success is defined by the value that we're delivering, by the features. And a feature is not done if the front end looks fine, but the back end hasn't even been started. or vice versa, or the data science people haven't come up with their machine learning magic that they need to deliver. Like, it needs to work together. That's why the concept of having a cross-functional team, where you're putting the people that are necessary to deliver on a certain feature end to end, normally should be inside the same team. I know it creates different kinds of problems, but that's what I mean with follow the work. Like,
yeah. I follow the work or follow the money, right? So I even like follow the money a little bit more even. And it sounds like a more generalized concept compared to product or feature teams. So you can group, that's you have front and back end. And then next step would be you slice the teams in a way that you have a clear focus on a business domain or on a feature that delivers then value. And follow the money is even more generalized, right? I like this quite a lot, to be honest. So this is, I guess this concept is very related to product or feature teams, right? Or business unit teams.
Yes, I would think about business units, but business unit is something that you use when you have become of a certain size. And we're talking about smaller engineering teams, maybe 10, 20 people. I think it's already exaggerating. You're trying to do premature optimization, because the problems that you're trying to solve when you are rather small probably is finding a product market fit. When you're trying to find the product market fit, actually you don't even believe that whatever you're building now from an engineering perspective will survive the next 5 years, because we need to pivot maybe more often than we want to, and we need to have a flexible, let's say, mindset in the engineering team, that what they are building is supposed to prove that, okay, there is the need for the value that this company is providing. And then once this is proven, then they can start actually building the system that is supposed to last for the next 5 years.
Makes total sense. So we as engineers should always focus on the business and not on the tech in the first place. I think that's super important. So when we now do this, so we have front and backend teams, and we restructured them and regroup them around like business domains or flows of work or the flow in general, then usually new challenges happen. So the teams then start complaining, hey, we now have 3 or 4 teams, but how can we make sure that we have this monolith still, because we're working as a backend team and there's still a monolith? How can we make sure that those 4 teams work in the same way in the monolith? How can we kind of have something that helps us with slicing and dicing the monolith into maybe smaller services that then are tied towards a business domain and can be used by a single team who would do this because we are no longer working on the tech, we are working now on the business domains. And I think then the elephant in the room, of course, is the wonderful book Team Topologies, where this has been highlighted in quite a good way, I guess, where you then need different team types, not only one team, a cross-functional team that is flow aligned, but you need different teams. And what teams would you use then? Or how did you use this concept in real work? So team topologies, of course, is about 4 teams. It's the stream-aligned teams, the flow-based teams, the enabling teams, platform teams, and I have to read this a little bit, but the complicated subsystem teams. So 4 different types of teams. And the platform teams would be teams that manage the platform, kind of managing your Kubernetes cluster or making sure that the uptime is good and manage your deployment cycles, maybe also your CI/CD systems, but also might manage your monolith and might manage slicing and dicing your original monolith into smaller pieces. So that's kind of the platform team. But how would this look in reality for you? How do you use these concepts?
Yeah. So let's start with the platform team, actually, because that was something that I used. Like when I read the team topology book, it felt like a revelation to me to some degree, because one of the let's say leading concepts that was used in this book was Conway's Law. Have you heard about Conway's Law?
I might have heard about this every single week of my career.
Okay.
Roughly.
Okay. Do you know it by heart? Because I had to write it down. I brought it here just that I can.
I just know roughly the concept. So, and what was in my mind about this is if you have like two teams that write a compiler, you get a two-pass compiler.
Yes.
So the way the teams are organized will determine and will influence heavily how the structure looks like underneath. And we had this already now. So if you have like a front-end and a backend team, you would end up with a backend monolith and a front-end monolith, right?
Right.
So, and if you have teams that start with business domains, they will create their own small kingdoms. You won't end up with a monolith. You will maybe end up with single services and maybe even some event-driven stuff. So this is for me Conway's law. But you know it likely better, right? So
I had to write it down.
Scientific definition.
I had to write it down. It's like Melvin Conway wrote a paper, and this was in 1967. That's how old this whole thing is already, and I really love it because like I'm more than 25 years now in this industry, and it's something that I got to learn about. Okay, yes, I'm very old, comparably to.
Depends. Compared to Warren Buffett, for instance.
Thank you, Raphael. Right? But okay, let's cut the chase here. Organizations which design systems in the broad sense of the words that we're using here are constrained to produce designs which are copies of the communication structures of these organizations. So that's what you said. Like if you have two teams and you tell them, hey, write a compiler, they will write a two-pass compiler. If you had given the same task to 3 teams, there's a high chance that they would have built a 3-pass compiler. And when we're looking at team topologies and we're looking into these 4 different team types, I have this in my mind. And that's also what I meant in the beginning, where I said that this is architecture. Like it's not technical architecture, it's organizational architecture, but it will influence how the technical architecture will evolve. It's something also that you can make use of by using the reverse Conway maneuver.
What's that?
Yeah,
you have a scientific definition as well?
No, actually, I will just say that you use this Conway's law to your advantage by hoping that if you are creating teams in a certain structure, that they will try to work with the system that they have created before that change to adjust that to their new organizational structure. So let's get back to your original question. How do I do this? So I started with something like a platform team, and it was interesting when I read the book and I heard about platform teams. I was also first thinking about okay, this is about infrastructure and Kubernetes cluster and like very technical. But in my context, I can say that I'm working currently with 20 plus teams. And actually what we have built was there's like an operating system in our company which is necessary, in the broader sense operating system, which is necessary to run all of our features. Like, oh, you need to have access to the user and the profile that the user has. And because we're operating under GDPR, one and the same user can have multiple profiles depending from which of our customers, B2B customer, they're coming from. And this user service, which we already have, is, from my perspective, a part of the platform. It's something that all the other teams need to have access to. They need to be able to access it. So the platform teams that I have created in my original context was, okay, what are the services that we have in our environment that are needed for all the other teams to be successful? And that's the actual platform. And then in addition, we had obviously also a platform team which is taking care about the whole Kubernetes and so on and so on. But it was already changing this kind of definition, what is a platform for yourself in your current situation? And this was like 3 years ago. Today, I'm changing these platform teams to become actually stream-aligned teams. And I'm doing this by handing them over more and more responsibility about certain features inside the product that we have.
It's very, very interesting. I mean, we left out one other big elephant in the room, which is the Spotify model that everyone quotes and nobody uses, or at least Spotify doesn't use it.
Tell us about it,
or
please.
Someone told me that they're not using it the way it has been described in online. So, but So again, we started with the front and backend teams. We then sliced them kind of and have now stream-aligned teams and maybe a platform team. And the question is, how do you, we have 5 teams that are stream-aligned. How each of the teams is using like React in the front end and some kind of backend technology. And how do you make sure that this is broadly similar? So that not one team uses React, the other team uses Vue, the third team uses whatever. And the backend teams all use Spring Boot, but not in the same way. It's deployed differently. Spotify then came up with a wonderful idea, which is an old idea. Just use a matrix organization, right? Let's have a front-end chapter. That's what the term they use. They use the term chapters, where maybe once a week, all the front-end engineers are coming together and they're deciding on coding styles, on tech to use, and making sure that what's being developed inside these silos, because we created now silos, that this is still something that is broadly similar across all the teams. Same for the backend. And so my question would be now, I mean, you mentioned the platform teams, and I like this quite a lot. It's not only about Kubernetes, it's also about the platform itself, which might be different things depending on the business context.
Yes.
And how do you unite these things? So you now have the matrix organization and chapters, or maybe a chapter lead, and you have the platform. And how does this work together in your context? Do you use those concepts? Do you find them interesting?
Yes, of course.
Easy to use?
So first of all, there is no blueprint. Like there's like, what I'm telling you now, or what we're talking about now, is something that is like used in my specific context. And it's actually also something that is changing over time. Like I'm currently thinking about like writing a bigger blog post about the past 9 years and how the organizational structure changed in that period. I do have stream-aligned teams. I do have platform teams. I do have complicated subsystem teams.
We didn't talk about this. What's a complicated subsystem team? Can you give a good because okay, there are those 4 teams, the stream-aligned teams. That's clear. The platform teams is now also clear. Then we have the enabler teams, and we have the complicated subsystem teams. And this is usually what's actually not used by many companies. I can talk about the enabler team,
and I will talk
what is the complicated subsystem team in your case?
So a complicated subsystem team is having very special knowledge about something inside your product that might be very important, and maybe even so important that you don't want everyone else to know, or where you need to have highly specialized skills. So this could be, for instance, the data science team that is training your AI. It could be some video specialists on a product that is highly depending on processing the video signal and, I don't know, using a 3D camera and being able to, I don't know, spot the joints of your body because you're using a Kinect camera to code a game for the Xbox.
Yeah.
Something that is very special. I used to work in a company that had an algorithm that only 2 engineers had access to, because it was the main functionality that provided the value that none of the other competitors were able to provide. That's a complicated subsystem for me.
Yeah,
my definition.
Yeah, that makes total sense. So enablement teams. What are these teams doing? And this that's also very simple to explain. So if you have to, for instance, pull off a change of technology. So let's say you were using HTML, CSS, jQuery in the front end, and now you're changing to React for multiple reasons. You need someone to educate the teams. Again, coming back to our team structure that we mentioned, we have now, let's say, 5 teams. They are stream-aligned, and these teams are currently using HTML and CSS. So then you would have another team with experts in, let's say, React, that then maybe join the team or educate the team on the usage of React, and also consulting with them and supporting them to move from HTML, CSS, and that's just an example, to React. And that's enablement or enabling teams, which come in quite handy if you have those tech transitions and so those changes. Would you agree? Is that a correct definition?
Perfect, yeah.
Do you use them?
So I would consider our SRE team as a mixture of
the SRE team. Okay, that's interesting.
Site reliability engineering.
Yeah.
Again, it's a Google concept. The DevOps structure that we have created is sort of a platform team and an enabling team at the same time.
Oh, that's nice. I like this.
Because part of the team is responsible for running the platform, doing the let's say administration and things that are necessary for the Kubernetes cluster to work, etc. And then we have SREs. They are part of the SRE team, but they actually go into the teams. They become part of the stream-aligned teams, and they help them in all of these, let's say, operational features and the observability and all of these things. But because they're engineers, they're also working on tickets, feature development, what's necessary.
Wow. And are these SRE engineers, are they permanently joining these teams, or is this just temporarily?
It depends on what permanent and temporarily means for you. So if an SRE is joining maybe for a year a certain team because they are working on something, for some people it feels permanent, but we normally deploy them temporarily, as long as it's necessary.
Okay, so to transfer the knowledge and enable the team to get something off the ground and maintain their systems themselves.
If we have a greenfield project where we're building something from scratch, then these SREs are normally longer in this team to help them get started, but also to make sure that whatever is being built in the, let's say, in the way that the aligned and agreed processes and technologies and so on are used and followed. And then they will phase out. And also, if they're working with teams that are working on something like you mentioned, like, oh, we want to dismantle the monolith. That's normally not something that is done within a week or a month. Sometimes, for us at least, it takes years. And then one or multiple SREs are supporting that whole project along the way.
Maybe we should talk about tech debt in one of the future sessions. Maybe.
We can talk about tech debt for sure.
Yes, that's part of that. Cool. That's very nice. Coming back to this team structures, one concept that comes in handy at some point, and that I've heard multiple times, is having staff engineers. And staff engineers is just a certain level. So you start as junior developer, then you become like mid-level developer, the senior. And at some point, you become a staff engineer. And staff engineers, so I had, for instance, the pleasure of talking with the Vault CTO, and he was using staff engineers quite extensively, and he was deploying the staff engineers. So staff engineers were like free radicals, and they could kind of choose themselves what they want to work on, kind of. And they kind of, not randomly, but they joined the most important teams and supported them, and also led partially those tech transitions, microservices, or let's say from larger services to microservices. And how are you using the concept of staff engineers? And is this just a level for you? Is this something that really helps the whole organization in terms of structure and influences it similarly to a team topology?
So what you are describing is, when you're thinking about team structure, then the career ladder also plays an important role, and maybe we can talk about career ladder.
We should talk about career ladders.
But so let's not make it about career ladders. And one of the career points that engineers can get is to a staff engineer, which is like someone who really knows their stuff.
Yeah.
And they're able to help others getting stuff done.
Yeah.
And I do have the same concept currently with my current company. I can say that it's not working exactly like you are describing, but the intention is the same. It's a fluid concept for me. It's also like I have something that I'm calling like principal engineers, that they are behaving something more like a domain architect. I don't like the architect title, so I don't want to call them architects. Yeah. Mostly because
that makes sense.
I want people to still code. I want people to be on the ground, and even if they are not like up to here into code, maybe at least up to their waist into code. Because if you don't, then they don't they don't know what they're architecting, and their job is to rather help others make good architecture decisions.
Yeah.
And I would say that something similar is what you are describing with the staff engineer or the tech lead. I don't know, like titles are also different in different companies. So you want to have someone in there that supports, again, the flow of the work, follow the money, the flow of the work to make good decisions, to make sane decisions, to make decisions that are not premature optimization, but also that are not leading us into a dead end, so that we can continue to extend what we're building maybe in the next year once the feature gets some extra attention. And I do have that, and I truly believe that these people are necessary at a certain stage of the company size. Like, I wouldn't need this kind of setup when I have like 5 people. I would probably listen to all 5 people at the same time, because it's easy for me to listen to them. It's easy for me to delegate also this responsibility to them, because it's still like very close to me. If I'm getting to 50, 60, 80, and beyond 150 people, me as an SVP, I will not have any chance to understand what's really happening inside the whole structure. So having people that I can trust and that understand where we want to go as part of the team structure, it makes a ton of sense to me.
Yeah, that's true. And would these special engineers, would they report directly to you? Because I had this last year, where we had very, very experienced engineers, and we also had to change the organizational structure. And these engineers then they are the perfect definition of staff engineers. But in this organizational structure, they would have ended up as part of teams, which they would have then report to the team leads, and then to the head of engineering, and then to the CTO. And this felt very, very strange for them, because they were with the company for so many years. They created all of the systems, and what we then did, and what is also very classic, is they were reporting directly to the CTO. So they were way above the playing field of all the others, which was totally okay for everyone. So, and then you have also, of course, if they're reporting directly to the CTO, that's reporting, sounds very official. But then as a CTO, you have also your regular one-on-ones with them and know exactly what's going on in the organization. And that's also very, very helpful.
Yeah, exactly. So in general, I believe that leadership, especially in the engineering domain, requires people to have either a split brain, be really good in tech and be really good in organizational topics, or that you're trying to put this on 2 different shoulders that together are working basically as a tag team on solving these problems together. Yeah. One more emphasizing the technical part, one more emphasizing the organizational part, but both of them being engineers and working together in making this successful. Oh. So I second what you're describing here. So in my current setup, the organizational responsibility for everything for the 180 plus people lies with me, while the technical responsibility, and therefore, let's say, there's a dotted line that goes directly to the CTO for exactly these people, including myself. So we as a group are working on the technical problems. And I find that very, very effective.
Mm-hmm. Yes, I've also seen this work very, very well. I think one topic that you also have to talk about is AI, of course, because AI has been part of like all of the podcasts these days, a super important topic. But it's especially interesting when it comes to, it's interesting for many, many reasons. But when we talk about team structures, the question is, how can we integrate AI into our workflows, and how, as you put it, engineering is about supporting the business. How can we as engineers or as engineering support the business best in the field of AI? And I've read, so now it becomes super interesting, because AI is, of course, a huge field. So we can also talk about machine learning and what we did in the last 10 years in the area of machine learning. But I want to focus on AI, which means something like agents, something like prompts, something like access to different repositories of information inside the organization, something like enabling marketing to use some agents that can then access things. So I think we're at the very early stages, but the need for the companies and let's say the urge to use something and make AI work and LLMs work in particular becomes very, very obvious. So what's your take on this? AI, team structures, supporting the business in this concept. And I have to be honest, I've read many articles from Will Larson, and he wrote some really good articles on how to make this work and what he does as a CTO right now. And the challenges I had in the past, AI was always important, but because it's so new, I didn't have this right now. So I didn't have the need to create an AI team to this date. So I'm curious, how would you make this work, and what's AI for you? It's massively important. But maybe you have another definition of AI, because maybe it's just about making... AI is also important because you have to make your engineers much more productive, and the engineers use Cloud Code and use Lovable and...
Correct. So
what is it for you?
We could make a whole podcast, probably 10 seasons, 10 episodes, and maybe even 10 seasons, and not still not talk about everything. So AI is huge. I think AI is as disruptive to our industry as the introduction of the internet, of what we now know as the
I would totally agree.
World Wide Web.
Yes,
I'm so old that I know how it was before that. I was one of the first people to receive an email address in my university when it was. Anyways, so let's focus on AI in the sense of the team structures, and in this context, because we can talk about this on how we can build the product, etc. But in the context of the team structures, let me pick something that you just said yourself. You have like front-end engineers and you have like back-end engineers, and I was like jumping in and saying like, maybe we need to have rather cross-functional teams so that we have every kind of capability available, and so on and so on. I believe this becomes less and less important for us with the use of AI. I think AI has become so good, especially in the past months. Again, I don't know how much you're using this. I'm talking to my engineers regularly, and they're quite impressed on what it can do. And it can do something that currently makes me think between something else, a different distinction, and that is, what is a coder able to do? Someone who writes code, who understands their technology inside out and feels comfortable, like, I don't know, I know C++, like the Matrix, I know Kung Fu, like someone learned C++ by like years and years of experience, and so on and so on. And what's a software engineer? What's someone who understands how to build software? With the use of AI, I believe that
that's the difference between programming and software engineering. Yeah. Programming is writing a couple of lines of code, and that's fine.
Yeah.
And engineering is something, well, I can run and I can maintain and I can upgrade those systems for the next 5 to 10 years or something.
Yes.
You know? And then I can grow the teams around it, and I know what it doing the performance and so many more things. A huge difference, programming, engineering.
Understanding what an exponential backoff is and why it's important for an API.
Yes.
That's something that I'm expecting a software engineer to know.
Yeah.
And if I have a software engineer who understands these, let's say, principles, how to build a system eventually, but their limitation is that they don't know, let's say, how JavaScript works or how React works, but they are quite a decent backend engineer because they know Go or they know Java or whatever, then through the use of AI, suddenly this backend engineer in the old terms becomes more of a full stack engineer, because suddenly if there's maybe an easy or let's say a mediocre task that needs to be solved in a different technology, these software engineers, from my perspective, will be able to solve that through the use of AI.
Yeah.
And that's huge. I can tell you 180 people later, hiring specialists is a pain. It's necessary, and I'm proud of every single person that I hired so far. Really am. But it's really in an environment where you want to grow and you want to be flexible and you want to follow the money. You need to have also people that are, let's say, willing to touch something that maybe they didn't learn in the past. And with the use of AI, suddenly I have a lot of people that can work on these things.
This reminds me of two more concepts that are now very related to AI, but they are also very related to making those organizational structures shoot successful, which is one of maybe not my secrets, or if you have these teams, front and back end, like all the engineers are only thinking in their domains.
Yes.
And if you then come to the team and propose, hey, let's hire a full stack engineer, it's kind of mind-blowing for them. And they are right, because you will always have your specialization. So if you worked your whole life in Java or C++, you will be a Java or C++ expert. But what we are looking for in terms of front-end full stack engineers is we want to have someone that is a specialist in one area, but also wants to contribute somewhere else. Because if you can write good C++ code, chances are high you can also write React code and front-end code. You won't be the best CSS juggler or React juggler when it comes to huge architectures, but you can contribute if it's and this then allows you as a team lead or as a CTO to assign stuff that has to be done in stories much more easily to those teams.
Yeah,
becomes much more fluent, and I can only recommend this so much. Hire full stack engineers. Of course, with a caveat that they will always be experts in one area, but hire people that have an open mind and want to contribute somewhere else. Makes your life so much easier. And this is then these types of people, when they start using Claude Code or Lovable or whatever, they are supercharging what they can do, and then you have the 10 times engineer. It's that crazy, but you have to have this full stack mindset, and you have to have the business in mind. So that's very, very important. And that
I like that.
AI then blends nicely into that.
It's basically an extension. I 100% agree with you. I set up a whole business unit in my current company, which consists only of full stack people, and it made my life, but especially also their life, so much easier because they feel that they can work across the whole product that's owned by that business unit, and now introducing the AI aspect to it feels more like an extension. I like the way how you have completed this picture. I like it.
Yeah.
And you said there's a second one.
There's a second one, and I think the second thing that's very, very important to me is that you can only create a fast-moving organization if you limit the amount of technologies that are in use.
Right.
And you can also rephrase this a little bit, or just imagine if you have 5 teams and one team is using C++, the other team is using Flutter, the third team is using Java, the fourth team is using TypeScript, the fifth team is using Rust. So, and they are all contributing to the same business domain, but this is a very complicated system. Like none of the teams can contribute to the other teams. It's very hard to see what the other teams are doing.
Yeah.
It's particularly hard finding staffs. Then hiring processes have to be adapted to each of the domains. This multiplies so much. So the other big recommendation when it comes to making sure that your organization works well and the team structure works well and can be morphed and adapted easily is you have to watch, as in the leadership position, you have to watch that you're using as few technologies as possible. And you see this with all successful companies. So Google was, I think, in the backend they were using, I think, C, C++, Java, and Go, and that's it.
Right.
These are, I don't know how many people they're having right now, 80,000, 100,000 engineers or something. Only these technologies. And then it's very clear, and then you can easily look into the repositories of other teams, and you can contribute to the code, you can make changes, you can adapt things. Super important. Keep the tech stack simple as possible. it's very easy to just start. Yeah, let's React is the new thing. Let's start with the React. When you were working with Angular the last 10 years, but if you have Angular experts, moving them to React is hard for many reasons, and it's also stupid because also for many reasons. Keep it simple.
I would add one more sentence. You said use as few as possible, and I would add and as many as necessary.
Yes, also true.
Both of this is true, because if if you want to build a native app, and in addition you need to have a web front end. If you decide for a native app, then you have to do your iOS and Kotlin development. You could also, of course, use something else, but you're basically in charge of that decision.
Yeah.
You could also go for a hybrid app, or you could go for a web-only thing, and then you can control this to an extent. If you are in a hardware environment, in IoT, and you need to, write the firmware for your circuit board that you created.
I know someone who has to do this.
Yeah, right.
Hands up.
And then you need to take the necessary technology that makes you the fastest, and that also is established. I also like to say, use boring technology, because boring, if you're growing, is important, because you can find the right staff. You can make sure that people are already learning this, maybe even in university, etc., etc.
Yeah, it's battle tested.
Yeah,
that's true.
I have one more thing here.
One more thing
on AI, because that's very interesting when we're talking about team structures. When we're both engineers, we're coming from software engineering, but we're always working with these designers and UX and product people. With the use of AI, I also believe that we can already see, like you mentioned, Lovable. It's like Lovable is something where a product manager doesn't need an engineer to just come up with a quick prototype of a product idea. But I believe that this goes in both directions. Of course, things are necessary for this to work. Like, for instance, if the designers have created like a design system that can be used, then maybe the engineer can just access the design system and build already things, and maybe do even some product management work with A/B testing and understanding some metrics and making decisions based on this, which normally is done by the product manager. And vice versa, the product manager can do something that normally would require them to have an engineering team. So I think this is huge. And I can only recommend to experiment with this and learn from it, especially because I believe that I don't know if there's a formula like we had for the CPU speed, doubling every year, but
that's an interesting take. Yeah. Engineering performance, does it double? Does AI help us to double this every year?
I intentionally did not go into the direction that AI will make engineers obsolete. I went into the direction that software engineering will become way more important, and therefore understanding how to build a system. And this means that the team structure suddenly, do I need to have a cross-functional team, might lose relevancy.
Yeah, maybe, yeah. So I also think that, and we should talk about AI in another session, because this is a huge topic and it's so important, from enabling, that's where I started, enabling the other departments and allowing them to access your systems. And that's true for marketing as well as for product management. If the product manager wants to use Lovable to kind of tune the front end and try out something new, then you have to enable this product manager so that he or she can deploy things automatically with the use of Lovable. I think that's our duty. But what this also means is that a front-end, back-end structure, or an organizational structure that's not like clearly focused on business goals and business domains won't help you in the age of AI. So it becomes even more important to keep your stack simple, to have a focused tech organization, so that you can be successful as an organization in the age of AI. Even more important these days, I guess.
I like that.
Yes. Did we forget anything in this huge area?
I'm pretty sure that there are many more things that we can talk about.
I also think we forgot something.
But we talked about team topologies. We talked about
the full stack engineer, about how you will evolve the teams.
We talked about a Spotify model. We talked about AI now recently.
Yes. Simplicity of the tech architecture that has to support here.
Having a fluid organizational structure, which means that this needs to be adjusted along the way of the growth of the team, of the company. You're never done building the right organization.
Yeah. That's your duty.
That already sounds like a interesting
take. Yeah. So I would say let's end it over here at this point, and let's see if we can make a second part about all the other areas that we maybe not have talked about.
Looking forward to that.
Looking forward to that as well.